Hello, everybody. This is Pete from Paw Labs. And yesterday was a pretty ferocious day for me. I was working on communication between the player and the server. So I've taken the client server code and combination of torn it up and rebuilt it. Okay. Now, the first thing I had to come up with is a command structure itself. I wanted the command structure to be something that's easily put together by code, but does not contain a million extraneous objects and values and junk. So once again, believe it or not, modules came to my rescue. So I've shown you in previous videos that you can serialize an object into a JSON string, right? So here was my solution is a two-level approach to a single command where on the right-hand side here, we're going to have some sort of command type. That's either going to take the form of a client request type, such as log on, log off, move unit, attack. There's going to be any number of commands. Each command, if you think about it for a second, has a different set of data requirements that come with it. Take, for instance, resupply unit. Well, resupply unit needs a unit ID, and he needs to know what element type that you're resupplying it with, what city the resupply is coming from, and how many, what's the quantity of the resupply. Move unit might need unit ID and then move to row and column. So you start adding up all the possible requests that a player can make in a game, and you're going to end up with a rather large and ugly list of possibilities. So my solution was to use a whole nested series of modules. So the basic structure is you have a command ID and then there's a text field. Okay. Now, a text field in code can be up to some ridiculous billion bytes or some, a gig or something to that effect. So based on the command type, this could just be a single text value, such as a player name, log on, player name, log off, player name, surrender, player name, quit. Something that doesn't require it's just going to be an empty string is save game. Okay, you may want to do a save game, and the server will take and save it to the next possible slot. Okay, so that's at the high level. Now, when you get to the more complex commands, let's say move unit, we need a unit ID and then a 2-row and a 2-column. Well, I have I've created a whole series of modules that are these individualized commands. So the overall command structure is going to be move unit. This text is going to be a serialized or JSONized or a JSON string of another object, which includes the fields required specifically for that task. Okay? So this is, if you look at it from a code perspective, it's going to get pretty ferocious. So I wanted to start with, well, I was going to say a picture because this is paint, so technically it is a picture, but a simplified form. Now, this is a bidirectional command structure. So from the client side, we have this client request down here. Okay, so that's going to take on the form of a type list of request types, and then the server responds, and it's going to take on the form of a response type ID. Okay, so these are, if you go think in terms of class builder, you have the classes and you have types. This is the list of types, which are the list of possible responses. Because remember, this is all lights out from the standpoint of human intervention. This all has to be programmatical to where the code knows what you're asking and expects certain things the way they got to be. All right. So back to the structure. It's very simple. You got a command, whether that's a request from the client or a response from the server. And then you have a text field, which, depending on its command type, can either be a single player value, like player name, or it can be a serialized JSON object for the more complex movements. Now, part of the design in this is to minimize the amount of data that's flying across the network back and forth between two players and the server, and it's allowing the server to try work with the smallest unit of data that I could figure out how to do. So there's the command structure. I've kept it up here for quite a while. I will go ahead and save this image in the image folder of the project so you have it. But now let's go look at some of the code. Let's see, if we start here in types, we have a request type that I've started, and it's got simple things like login, log out, surrender, end phase. So we have a current phase. The game is going to be played in phases. You're going to have movement followed by combat. Then the other player gets movement followed by combat, and then both get resupplied. And then it repeats itself over and over and over. So when a player is done with a particular phase, he can hit this command, which says, okay, you're not getting anything else till we get to the next phase. You've got move unit, resupply. There's going to be a whole slew of them, and then save game. For the response type so far, I added one in code last night, but initial structure of this or list of these is your request was successful. Okay, so move unit, you successfully move. That sort of thing. Or you want to move the unit, but an enemy unit is already in that spot, or you don't have enough movement points. It'll say failure is the ID. So then the text would be unit doesn't have enough movement points to acquire the cell or something to that effect. And then there could just be a game message, okay? Such as, well, success. I'm okay. This is a list in progress. So as we mature the game and start adding to the player, then we'll flush this out. So now let's come on. Oh, I didn't need you, did I? All right. So let's come over here. So here we go. I knew I did more in code. So we have log in, log out, surrender, end phase, save game, move unit, resupply unit, set city production are the ones that I'm building. If we look at the response types, we have success, failure, assign name, and message. Now, assign name may be an odd one. When the player hosts the game, he gets first pick, or she gets first pick of what player they want to play, which automatically leaves the other player in the game to whoever's going to join the game. So when whoever starts the server claims that identity as his identity, and then when you join the game, it's going to actually have a different routine that says, great, welcome to the game. Here's your player ID. All right. Now, if you, well, we'll get to it. Let's see. So that's the responses and the requests. Let's look at the client side payloads. Okay, so I have included instead of, yeah, I did it this way just because to me it makes more logical sense. Um, we have a standard module here, and this would be client payload, which has the request type and text, right? Single element or JSON object. So I have two public methods or procedures attached to this client payload, which handles the get the JSON, which takes the object and then creates a string and passes back the string, or it loads the object where you take the JSON string and give me an object and I load the object. So in this way, the module itself handles all the commands I need for the module. Okay. So all of the modules are built this way. They're almost identical in that you have a structure, a move unit structure, needs a unit ID and a 2-row and a 2-column. Once I have the unit ID, I know where the server should know where the unit is. And what the client is doing is saying, I want to move this here. And he'll go calculate the movement and all of that junk and say, yep, you can. And or no, you can't. And so that'll govern movement in the game. Is this going to change? Probably. Until I actually get to writing that code, this is all theoretical in nature. So then supply a unit. Well, supply a unit needs a different set of data. It needs a unit ID and a quantity. Probably is going to need, well, right now, the way we've designed it, or I've designed this, is a unit is one element type. There's no mixing element types. Okay, so it's either an army unit, it's infantry, or it's artillery, or it's tanks. So you cannot mix and match and put armor and infantry and tanks in a single unit. Okay, so here I don't need the element. What is it, infantry that you're loading? The unit will tell the server, oh, this is an infantry unit. He's obviously talking about infantry. And then what city is he getting his supply from, his resupply from? Setting city production. Well, this is going to be a different, again, we need to know what city are we setting it for, what element, what do you want built at the city, and then how many do you want. So I can foresee this as a screen that says um, set the city production, and you've selected the city. He's earning 1,000 points or 500 points a turn, and then you select an element type, and it says, hey, you can build 27 tanks in a turn. Do you want to do that? And you're going to say yes. Now, it may come down to I only want to build 10 tanks, and then you do it again and say, okay, we're adding to this collection of what is this city producing. He can produce up to 3 units, types, element types. And so maybe he's producing 50 infantry and 10 tanks or something if he has the points to pull that off. So that's the concept behind this guy here. Now, the server side of that, the response type is, as you can imagine, a whole lot less. Because all it is right now I don't have a whole lot on that. We have this server, let's see, client payload. What's this server object? Okay, yeah, this is the server object. Same thing coming back the opposite direction. is what I believe this is. So you're looking at declare module server. Oh, no, that's not right. The server object is the startup object that is passed from the person who is hosting the game. When he says, I want to host the game, it creates a server object and then writes it to um, a file. All right. And then it launches the server under a separate thread. The first thing the server does is goes and reads that file to where he knows what's going on. What do you want me to do? You want to run this game file, and then you want to set up a server on this port and this server. Originally, I had this in here. I believe I'm going to eventually take it out because initially I was going to have him automatically log the player in as being the first player, but I since have come back and said, no, I want him to send a separate command. So anyhow, same structure as the previous ones I was just showing you. This server object knows how to get the JSON he knows how to basically serialize the JSON from the object, and it knows how to take the string and reload the object all built into himself. So can these be generic procedures? Probably, but I like to keep them threaded, I guess would be my phrase, my thinking on that. So let's see. Why don't we take a look at the I want to look at the server. Some of the changes I've done to the server here, the Wargame server. So you can compare and contrast this if and you want to the original video on the client server. So what we have some enumerations here that we're going to need and use. We do all our includes. Basically, the server is really going to run the game. He has to have the game modules down here in order to know what's being done. So to be able to answer the questions, to spin through the wargame object itself and say, okay, you're allies, you're the Nazis, here's your units, and be able to keep everybody in sync, okay? So I've set the buffer size at 4K. And the question, of course, would come back to why 4K? Is there some magic number? And the answer really is no. I just always have liked 4096 as a number itself. I've always thought it was a neat number. So I also considered the thought of needing to send bigger buffer sizes, and they're going to be slower. And I wanted speed, and the vast majority of these are going to be much smaller than that. So they'll be really fast. I don't want a lot of wasted space to be dealing with. So yeah, that's just an arbitrary. I pulled it out of my hat. We have the structure of a person, which is it's slowly beginning to change. We now have a player ID, and his name, gender is going to get reused. The package type and payload and CNUM, and some of these are they're there from the standpoint of tracking the person. Let's see. This didn't change much. I've put in 2 new functions of login success and send other player name. So what this is doing is I have a response object and a command object, and so those are globals way up here up here. So this is the server response, and that's the client payload. So I reuse those for every command. And so remember that each command is processed in its own thread. So it's got its own copy of everything for that instant. and I do mean instant. This runs so fast, it's kind of mind-boggling. But so it has its own thread to do whatever it needs to do. So this is where it returns the response object. We look up the player ID, that kind of stuff, against the the, the current work map and stuff like that. Send the other person's name. This one's a little longer because this person has to connect second, so we've got to see what's already been taken, and then he gets the response back to issue to him, and then that's in his response object. These are left over from the original code. I haven't gone in and deleted them yet. Let's see. I guess that probably is a big chunk of it. The next actual chunk of change is in the network thread data. So this is the actually the processing loop of the separate thread creation of a message comes in, it spawns into its own thread of execution, and it executes, and then it blows itself away. He takes care of all of his own homework. If he created anything, he destroys it. Most of what he does is shared for his instant in life. So let's see. Most of this is the same. I've built this such that I've added a compression option, so it'll zip messages that are over 500 bytes long. It'll actually zip them and get them down much smaller. Predominantly, that 4K size up here is for transmitting the maps. Okay, because what I'm planning on doing is having the server send to the joining player the whole game. He's going to receive the game that the hoster started. So all the sprite sheets and stuff are going to be sent to him, cut up into slices. And if any of you are actually out on the PureBasic website, I actually put my slicer out there on the forum and said, hey, is this the right way to do this? Does somebody have a better idea? Here's what I'm trying to do, and here's the code that's going to do it. So I've already written the slicer. I'm just seeing what kind of response I get. So down here, this is the hard-coded login procedure, or the hard-coded procedures based upon the current player's state. So if you come in as a state name, then like that, this is going to be the hoster. Then we will actually come back with a, what are you sending me package type size? So your package type size can either be a message or a zip file. So then that gets handled. I've started work on the sending the name for the second player to join in. So once we know that number one is in place, the next person who comes in gets a send name prompt, and then he sends back the available name. Let's see, these are all just left over from the original code. I haven't deleted them yet. I'm trying to think. That pretty much is it. Okay, then. So without further ado, I'll go ahead and run this. Make sure default target is the player, and we can hit play. And so now, yes, I've modified this screen. Now when you select the game, you get the synopsis and turns down here to preview before starting the game. And then you can actually say host the game or join the game. You are looking at new games if you want saved games. If you want new games, then back and forth, that just works as a toggle. And then you can come in to host the game, and here's the game that you've selected. Here's your IP. Here's the default port. You can choose to be the Allies or Nazis. And when you start the server, numerous things are going to happen. First, under a new thread, it's going to launch the console for the server. Okay. It's also going to start writing to this area. This is editor gadget down here. It starts writing to this as to your progress. And then I have a debug window that kind of pops up showing me some stuff, which is, no surprise to anybody. So let's look at the server screen here. So our server has started. Maximum players is set to 2. We're on this port and ID and IP, and we have the allies connected. Okay, great. Thanks, server. Good news. Okay, so over here we have my debug code. You can actually get the response. This is the response that comes back. What we have on the screen that eventually will be the only thing they see is the server is started. I should probably say Wargame server has started. Allies successfully logged in, awaiting your opponent or something to that effect. But for the moment, we have our 2 commands that we know were successful. At this point, I'm going to have to start up another instance of the game to be the Nazis and then log in, join the game. So I haven't written that yet, but that's the next step. I wanted to give you this update to show you what's going on and how it's progressing. This is a first for me too, folks. I've never written a client server that's going to be this intense in code. Most of what I've done has been pretty lights out, easy stuff. So this is a good challenging thing, and to do it live puts a little pressure on it, which is almost fun. So thanks for your time. Enjoy the video.